All right, we're beginning chapter 3, and in chapter 3, the first section, which is section 3.1, it's simply titled as definitions. And not a whole lot of creativity that the book has there on the name of this lesson, but really that's all this lesson is it's talking about definitions. And let's get right into this. Let's take a look at, let's make sure we understand what parallel lines mean. Now, I do want you to write this down in your notes and write down the definition of parallel lines. Now, parallel lines are simply lines that do not intersect. So in other words, if these two blue lines kept on going and going and going, they're never going to cross. That's what we mean by parallel. Now, if I label this first line as line M and this second line as line N, I would say then that line M, I'm going to use my symbols, is parallel to line N. So right now, I guess the biggest thing is, most of you probably already knew what parallel lines were, but the symbol for parallel. And the symbol for parallel is this right here. Some of you are still trying to understand that congruent symbol. Well, now we've got another symbol that we're going to use quite a bit, and that's parallel. And the reason that we use the symbol is just so we don't have to write the word parallel out. So again, parallel lines are simply two lines that never cross. Now, intersecting lines might look like that. They're going to be two lines that do touch, and they're going to intersect. So make sure you understand the difference between parallel and intersecting. Now the new one. The new one is called skew lines. And again, make sure you write this definition down. Skew lines are non-coplanar. Now we go back to a word that we haven't probably used for quite a while. Non-coplanar means two lines that do not lie in the same plane. So non-coplanar, two lines that do not lie in the same plane. Now notice I've got kind of a box shape sketched out below. And obviously the box, it has 6 sides. Now notice on one of the sides I have a red line on the top, and on the side of the box I've got another red line. Now skew lines, they're neither parallel nor are they intersecting. They're neither of those skew lines. And the reason for this, and I'm going to see if I created this so I can move this line around. Yeah, not quite. If I had that box and say I had that red line that was on the top, and it kept on going and going and going. Now it's very possible where that other line on the side, if it kept on going and going and going, that they wouldn't cross, they wouldn't touch, because maybe this red line is a little bit further to the left over here, and maybe this red line on the top is a little bit down here. And if the lines kept on going, they're never going to cross. I mean, they're not going to touch each other. So skew lines are neither parallel nor intersecting. Now, if they did cross or they did touch, then they would not be considered to be skew. So that they would be neither.
Tina Sosby to the art room, please. Tina Sosby to the art room.
Okay, so those are what we call skew lines. Now, parallel planes. Let's take a look at the same type of box. And notice I have the symbol for parallel, okay, parallel planes. Now, parallel planes are two sides or two flat surfaces that will never touch. So, for example, if I outline, say I outline the front of the box, and then say I outline the top of the box, and those are two different planes, right? Now, notice that they touch. They have that edge that's going to touch. Those would not be parallel planes. What would be parallel planes in this box shape? Well, it might be the top of the box, and it could be the bottom of the box. Because no matter how far they keep on going out, they're not going to touch. You could have the two sides of the boxes. They would be parallel planes. You might have the back of the box and the front of the box. Those would be parallel planes. So parallel planes, two sides that do not intersect. All right, theorem 3.1, especially, make sure you write this down. It says if two parallel planes, and we just got done talking about two parallel planes. An example might be the top of the box and the bottom of the box. That would be an example, and there's others. where you have parallel planes. So if two parallel planes are cut by a third plane, so cut by a third plane, meaning that a third side is going to touch those two planes. So maybe it's the front. Notice the front would touch both those planes. If two parallel planes are cut by a third plane, then the lines of intersection, where's the red plane touch both? Where's the red plane touch the top? Where's the red plane touch the bottom? I'm going to outline that. It touches right there, doesn't it? It says, then the lines of intersection are parallel. So in other words, if two parallel planes are cut by a third plane, then where that third plane touches the top and bottom, those lines are parallel. It certainly looks like they are. Now there's a certain symbol that we're going to use for parallel. And if I have an arrow going through both of those, we're symbolizing that we mean those two lines to be parallel. And we'll talk more about that in class. All right, a transversal. And you can see why this section was labeled as definitions. We've got a few of them. Okay, transversal is simply a line, the red one here, that crosses or intersects two or more coplanar lines in different points. Sounds complicated. All a transversal is simply a line that crosses two other lines. So would you agree that my red line crosses two other lines, the two black lines? And the answer is yes. Now, we could have another line. I could have another line up here. And notice now my transversal crosses three lines. So in other words, it touches these three lines in one point. Transversal. All right, we're kind of nearing the end of this here, but you've had these terms before, but you probably didn't understand them completely. We have what we call alternate interior angles, abbreviated as I have it there in parentheses. Now, it's the interior angles on opposite sides of a transversal. Now, first of all, identify the transversal here. It's line L. That's an L. It's the red line. That's the transversal. My transversal crosses two other lines. Now, those two other lines might be parallel. It kind of looks like they're parallel. They may not be parallel. It doesn't matter right now. Now, what do we consider to be the alternate interior angles? Alternate means they're on either side of the transversal. Interior means they're inside, and I don't really want to use red again here. They're inside the two lines. So in other words, interior means they're inside the two lines that the transversal crosses. So angle 3 and angle 4 are interior. They're inside those blue lines. They're inside the two lines that the transversal crosses. And they're on opposite sides of the transversal. Angle 3 and angle 4 are alternate interior angles. There's one more pair. And excuse me, I made a big mistake. Actually, it's angle 3 and angle 6 are alternate interiors. So they're on opposite sides of the transversal and they're inside. All right? Angle 4 and angle 5 are alternate interiors. Now, you've learned in the past that alternate interior angles are congruent. Right now, we're not introducing it that way, because if these two blue lines are not parallel, they won't be congruent, but that's kind of where we're going. So angle 3 and angle 6 are alternate interior angles. They're one pair. Angle 4 and angle 5 are alternate interior angles. That's it. None of the others are. So alternate interior angles, they're on either side of the transversal. They're inside the two lines that the transversal crosses. Same side interior angles. Now, same side interior. Interior means they're inside the two lines that the transversal crosses, but they're on the same side of the transversal this time. So angle 3 and angle 5 are same side interiors. Angle 4 and angle 6 are same side interior angles. So 3 and 5, 4 and 6. Understand where they came up with this name. Same side meaning they're on the same side of the transversal. Interior meaning they're inside the blue lines as I marked them. Now let's go back to one. Remember when I made my mistake? I said angle 3 and angle 4 are alternate interior angles. They're not, because angle 3 and angle 6 are. That's one pair, and angle 4 and angle 5 are. What are angle 3 and angle 4? What do they add up to? Using your angle addition postulate, they add up to a straight line. So angle 3 and angle 4 would be what we call supplementary. All right, last one we have is what we call corresponding angles. Corresponding means one of the angles is outside the blue lines or the two lines that the transversal crosses, and one of them's inside the blue. So in other words, and they're on the same, you might want to make a note on this, they're on the same side of the transversal. So 1 and 5 are corresponding. Another pair would be angle 3 and angle 7, right? Because 3 is inside, angle 7's outside the blue lines. Another pair would be angle 2, it's outside. What corresponds to that? Angle 6 does. And then one more pair, angle 4 and angle 8. So actually we have quite a few pairs of corresponding angles. One of them's outside the two lines that are crossed, the other one's inside the two lines, and they're on the same side of the transversal. So I've given you some diagrams, I've kind of talked through some of these definitions in detail.
Mark Harms, please come to the kitchen. Mark Harms,
again,
please come to the kitchen.
The topic was called definitions for lesson 3.1.